Good evening, y'all. Welcome back to another Sunday night shenanigans with tiny moving lights, etc. Oh, look, Fusion's finally booted up. So I started Fusion 360, which is what we'll be working in for a good chunk of tonight. There it is, booting like like 3 minutes ago. And it, sometimes it takes a while. It had to update, and then it was like, I'm just going to take over all of your monitors with my splash screen. Did you want to start a stream? Too bad. I'm still booting. So here we are. It's already going tremendously well. We're going to work on more kabuki-drop stuff tonight. And I have already had a bit of a brainwave. We all remember the time change. We're already here. So let's see. If you were somewhere and you hadn't remembered daylight savings time here in the US, you would think it was still 6. So we might see some newcomers coming in at 8 p.m. for 8 p.m. Central Time, at least. I know we're in a variety of time zones. We'll see. We'll see if people straggle in an hour or so. Maybe toward the end of the stream. I'm hoping to keep it to a tighter night tonight, because it's been another exhausting week at work. We're almost out of crisis mode. I feel like we're almost back into the slipstream of things. But of course, as the museum opens back up, all the things that we were like, that I think still works. The moment it, of course, encounters the public, things start to break, or they run for 10 minutes, but not for 8 hours anymore, and what have you. So a busy week and a busy week yet ahead, but I think we'll do some fun stuff tonight. Good to see some of the usuals out there. Hi, Chris. Hi, Broke Both. Good to see you both. Yeah. Nothing else really to say except for tonight's beverage of choice. Tonight, courtesy of Mary, my lovely wife, I'm drinking a Vallejo India Pale Ale from Half Acre Beer Company, just up the street here in Chicago, which is very tasty. Yeah, I've had it before. I love it a lot. It's like super refreshing and juicy and tasty. If you're drinking something interesting, always curious. As always, no pressure. Water is a perfectly delicious beverage. Yes, and Chris says, for those in the States, it's Pi Day. It's March 14th. It's 3.14 day. For Pi Day, so my wife had an event with the Stage Managers Association today themed around Pi. So she got for us an incredible, I'm going to get this right, balsamic raspberry pear pie with like a crispy cinnamon crust. Oh, so good. With vanilla ice cream and a little balsamic drizzle on top as well. Just knocked it out of the park. So that's what I'm looking forward to at the end. I frankly inhaled a slice of pie immediately before this. I'm probably going to do the same after this. I was sort of like hoping, we had dinner like hours ago, and I was like, well, if I time it right, and I have the pie right beforehand, then I'll have the sugar rush to carry me through the stream, and then I can reward myself with after-stream pie, and it all works out quite well. Brokewood gets YouTube notifications. Well, that's probably the smartest thing to do, right? It's just to subscribe and hit that bell and all those good things you can do on YouTube. Brokewood, I can always count on you to like segue me into a plug, and I really appreciate it. Let's see. Chris is drinking more Riverlands this week. First anniversary barrel stout. Ooh, that sounds very tasty. Yeah, and gosh, speaking of anniversaries, so today is March 14th here in this. It's March 14th here in the States. It's March 14th. Most places, I imagine. Tomorrow, March 15th, is the 1-year anniversary of starting to do regular streams. Because right after, of course, things shut down originally, that Sunday, I did what was then Electronics Bash Episode 0, which was like, here's like talking about some electronic-y stuff on a workbench, and the week following that was the introduction to Arduino that launched what was the major project of mine on these streams the first 8 or 9 months. And so like it's weird to measure time in that way. I mean, time is weird all over, right? And like I'm not doing anything in particular this week to think about that, although maybe next week it'd be kind of fun to do like it's been a year. Maybe that's finally like workshop tour week, which might just be a vanity project for me, but I think it'd be kind of fun to like really not to like just like show off my workshop, but to talk with y'all about workshop organization ideas and share what I'm doing and what I've discovered and hear from y'all like, oh, that's a different way I could do this, because like I haven't seen anybody else's workshop in a year either, frankly, and it'd be good to like refresh some of those ideas. Thanks, Chris. Yeah, it's a wild thing to think about having done this for most weekends for a year, but it's also kind of cool, and it's cool to see like some of our regulars and people who, Chris, who was here like way back last March, and Broke Both, who's been with us for the last several months, and new people coming in all the time, and maybe people out there who don't like saying hi in the chat, but who have been a part of this experience for a year, who I don't know. And that's also really cool. It's kind of like, it's a little theatrical in that way, right? It's like, I don't know. It's just interesting. So happy a year to all of y'all out there. And in the vein of doing things for a year, let me show you what I'm thinking of to do as we push on into this second year, right? So this is what I think we're going to work on tonight. It's going to look like I haven't done anything in a week, and that's mostly true, but here's what I'm thinking. Last week, we spent a chunk of time working on the coupling mechanism for the Micro-Kabuki drop. And for those who might be watching this and before they've watched last week's thing, you know, the tiniest of summaries, right? The idea of a Kabuki drop is that it's a sum mechanism for a stage. Maybe it's a play, maybe it's a rock and roll concert that has a curtain suspended, and then, excuse me, allows it to fall. Hey, Thomas, good to see you. Thomas, we were worried earlier that some people might have forgotten to set their clocks for it, but I think, you know, people also know that, like, we don't really do anything in the first 5 minutes other than say hi and how much I like y'all, so you're basically right on time. So last week we were working on coupling a shaft to a servo motor to allow us to have a very simple mechanism for orchestrating a kabuki drop, right? A curtain is suspended on this by means of some pegs, and then when it rotates downward, the curtain slips off of those pegs and falls, right? That's a very simple kabuki drop mechanism. Hey, Dave, good to see you. Yeah, Chris, I found some brass rod, although this is not quite the diameter I had been thinking of. I thought this was 1/4 inch when I pulled it and was messing around with it earlier. I have some... so this is, I believe, 3/16 inch. If I take the calipers to it. Yeah, so that's 3/16. I have some 1/4 inch scraps around here and some 1/4 inch dowel rod that we can compare to if we really want to. But this might be our test piece for tonight. Oh, very good. Jeff Sachs, hi, good to see you. Want to use a kabuki drop? We built a bad one for Sound of Music. Delightful. Yeah, I mean, the kabuki drop, right, is like, it's a really cool effect, but there is always the danger of, like, okay, your mechanics are probably, you know, many dozens of feet in the air. If something goes wrong, do you have the capability of fixing it mid-show? You also have this kind of interesting issue, which we're not going to have a problem with, you know, in a in a 1/12 scale kabuki drop, right? Of you have a sudden change in weight on a pipe. So if you're in a counterweight fly system setting, you know, if you have a sizable amount of fabric, you know, take it like a large proscenium theater, maybe a 40-foot by 20-foot proscenium, right? Even if that curtain is something relatively lightweight, you know, you could easily be talking about 100 pounds of fabric over that proscenium. And so if you suddenly remove that weight from your counterweight lines, from your counterweight, you know, from your pipe, then you're out of weight on the other side. And what are you going to do to compensate for that or secure your arbor in your counterweight system? Just like practical concerns that you have to think about. If you're in like a dead hung or a hung on motor situation, it's not really an issue, right? It doesn't really care how much weight there is on it, unless you're talking about such a heavy curtain that removing its weight from the line set will cause the rigging to jump, you know, under the release of tension, but generally not a huge issue, right? It's really only an issue in counterweight systems. And definitely not an issue in micro-scale systems, let's call it. Ooh, yeah, Thomas prioritized dinner over 7 p.m. Listen, Thomas, I was telling these guys I just wolfed down a delicious slice of pie day pie, so I am 100% on the food train. So what I thought we would work on tonight to continue this project, he says, just checking his text messages, unrelated. I always think back to the time that, like, I was, like, the chat had broken and Palmer was furiously texting me to be like, hey, it's broken, please stop. So now I'm always like, oh, is that a text? No, it's congratulating some friends who have just adopted a child, and it's all very exciting. Are you doing drops with massive trucks? No. No, in fact, sort of the opposite tonight. So one thing we need based on last week's design, and for many designs of this, is some way to, here, we'll zoom out a little bit for context, right? If we're looking at this sort of right side up, if it was hung from above and the curtain's going to fall down this way, we have a shaft of some kind here suspended. And my original thought, and we've sort of drifted away from this, and I think that's good, was to have 2 servos, right? One on either side, and they would control the dropping mechanism, the rotation of this this rod that would cause it to dump off. A simpler way to achieve the same thing, right, would be, as Benny pointed out last week, to have a single servo and then some kind of support, you know, either at the far end, or maybe we need one at the far end and one in the middle, or what have you, so that really we're only controlling the action of a single servo, instead of having to synchronize 2 of them exactly together. So simplicity is good. One thing that did occur to me, if we do end up, for whatever reason, needing the torque of 2 cheapy servos, I mean, one thing we could do is go to a stouter servo. Even just the metal-geared version of these cheap hobby servos would help. Another thing we could do if precision ended up being a problem, right? Because the issue of having 2 servos is, A, they may not line up exactly, and B, like, if there's nothing that's electrically necessarily preventing... Let me get rid of that view for a second. There we go. If I, secure this shaft to both of these servos, and I tell this servo to be here, and it's static, and I just all of a sudden tell this servo to turn 90 degrees, there's nothing except, me not screwing up the programming to prevent that from happening. And we should not bet on me not screwing up the programming, right? And so the servos would essentially be fighting each other, and who knows what position they would end up in. One way we could alleviate that, it occurred to me, if we needed 2 servos to turn this, would be to use something like a servo Y-splitter, of the kind that's really common in... actually, I take it back, we couldn't. What I had been imagining was, in the RC control world, right, say you had 2... servos controlling maybe 2 different parts of your elevator system that you always wanted to move in sync. You basically just put a Y splitter on your servo wire so they always move together. Or, of course, if you flip one of them upside down, they always move in anti-parallel. So like if you were controlling the elevators on your airplane, then you could have have them basically be controlled by the same signal and power lines, but by mounting one of them upside down, as one moves up, the other moves down, as one moves down, the other moves up, and so that both simplifies like the electrical connections, because you only need sort of one servo control point to control both of the things, and then they always move exactly opposite to each other, or exactly the same as each other. The way that I have designed these mounts, it's occurring to me now, I don't think that would actually work. I think they would then always move, counter-rotating to each other because they're facing each other. And there's not such a thing as a servo Y-splitter that causes one to be actually the inverse in rotation of the other. They would always move together. So that, as I say it out loud, I was like, hey, here's something you could do. You couldn't do that. Things would break. But we could pursue the idea of some kind of external hook or support or something out here, just to provide like a little mechanical support. So, that's what I have been thinking to work on this week. And I wasn't quite sure exactly what pathway to pursue, or like what the form factor would be, like what does the bearing shape look like, how big is it, what's the attachment to the truss. And then I had a brainwave. We already did some really good work on a hook structure for the hanging clamps for the Demilight, right? And, this is, partly it's fortuitous that I've grabbed this 16th-inch piece. The members of this truss, this 44mm box truss that we've been using, thank you, Cookie, as always. I feel like I keep forgetting to put the link to this stuff in the description. I probably have again. D3D truss on Prusa printers is the place to go. But this hook design is both, I know its properties pretty well from having printed a bunch of them by now. It's mechanically sound, it's a little bit flexible, and it fits a 3/16 shaft really well, or it fits a 1/4 inch shaft with a little bit of tightness. And so, when I say 1/4 inch, right, a 6mm truss member here is just a tiny bit smaller than a 1/4 inch, which I think is 6.35 millimeters. I've got that right, is a 1/4 inch. Let's see, a 1/2 inch is 12.7 millimeters. So yeah, so a 1/4 inch is 6.35 millimeters. Let me see here. You get to just look at that pretty thing on the table while I go up into the bins behind the camera here to see if I can just real quick find that 1/4 inch section. Not that 1/4 inch is like, an absolute design requirement, because we're gonna build this kabuki-drop shaft a little bit from scratch, as it were. But I'd be curious to know, like a 3/16 smooth shaft fits great. Does a 1/4 inch shaft fit well enough for our purposes? I'm just curious. Actually, now that I look at it, I think it's I have a bunch of 3/16 segments here, which kind of makes me want to standardize on 3/16 just because, like, if I get to pick what the design is, I'm going to use the materials I already have, right? And it's like not an uncommon size, right? You can get 3/16. Oh well, there's the tum. For those of you who are like waiting on like the pool for when the first tummy cam was, 15 minutes. 15 minutes was the answer. I guess I do have. I was thinking about stock materials I have in 1/4 inch. That are readily available. what I have is, so you can still see in the camera there, the dowel rod from the original hanging position of the Demilights. It's got 1/4 inch dowel rod, but that's a little bit of a pain. Oh, I've got it. Hang on. I bought some more dowel rod recently for an unrelated project that I think is 1/4 inch. Yeah, there we go. Okay, that'll do fine. Yeah, and as Chris points out, right, like we could, because it's all parametric, right, we can do some design based on a given shaft diameter and then, you know, adjust it if we need to. I'm just sort of curious. So this is a 1/4 inch oak dowel from Menards, our local big box hardware store. Yeah, and it's just going to be a little bit of a tight fit. So if we snap that on there, it's actually a really nice fit. So that's a nice tight fit on there. So like if I was, this would be a good fitment for a clamping application, right? So these stock clamps, which I should put up at some point, right? Because we seem to be pretty standard on them by now. Good tight fit for clamping. There's just not enough rotation there to be really practicable. And I don't know that there's actually a good reason for standardizing on this hook specifically between a clamp and a bearing application. But what I'm getting to is I'm thinking about just reusing this clamp design in the bearing for this part. So like there would be basically a mounting plate here that would have 2 of these clamps on it and would have a third central point that would allow for a single one of these clamps to be mounted in it. So here, let me sketch this out before we get too deep. Of course, all of my sketching materials have been cast to the 4 winds by what would really generously be called a cleanup effort this week. But here we are. So looked at from, let's see, from a certain perspective, just putting this into my brain before I try and draw it here. So it would be something like it's got a segment there. It's probably got a little additional material around the outside. It's got another nobule there. It comes around like so. And these are our standard hook attachment holes, I guess, in that orientation. So this shape has our cruciform hook attachment point inside of it. So we'd have our 2, mounting hooks, I'm running off the screen a little bit there, hanging down here for hanging the thing. And then we'd have another cruciform hole, cruciform just being, cross-shaped, of the kind that we know and love. And coming out of that, I guess that hole would be obscured by this additional point to put a hanging hook, and that's where the actual bearing surface goes. So in installation, right, it would be in this orientation where this is hanging on a pair of truss members, or just like with our Demilight hanging design, right, we could do 2 opposing sides of a truss, or we could do, the front member or the back member of a piece of truss. So we have some hanging options. And part of the reason, so like this is a cumbersome and complicated way to make this part, but one of the things I'm excited about is the possibility to have this adapter plate, right, which essentially is a 2 up, 1 down, if you will, plate. Like if we took the existing front of this servo mount and chopped it off here, so we just left these 2 mounting points, and then put a third mounting point upside down in the center. because I think standardizing on this like as a snap mounting point is kind of an interesting possibility, and allows us to do things like if we want to have like easily installable like snap-in points, right, to like, you know, snap another piece of accessory up in there, we now have like a small fit-to-purpose mounting form factor for that. Let's see. Chris says, can you make it so all the hooks are the same and the jointing point is the oddball? Chris, yeah, that is I think what I am thinking. So each of these segments, each of these hooks, you know, crudely illustrated here, is one of the standard, you know, Demilight hanging hooks that we've been working like this time. And what we'll be designing tonight is this. I think of it as a plate. I guess it's going to be more of a coupler, right? This shape that has two up and one down snap-in points for those hooks, if you will. These would be on 44mm centers, right? So they can span across a truss. This would be centered between the two of them, just so it can snap down in that way. Another possibility for this is if it's small enough, we have the possibility to maybe use it to easily suspend things within the truss, right? Like we could use this as the start of an attachment, which this part is too large to do, but so that this piece could, you know, live up in here, hook on top, and then have a point which hangs out the bottom, essentially. Might be kind of an interesting thing to have around, or maybe it's unnecessary, right? Maybe this is all not going to be like just for this kabuki purpose, but I think it's got some possibilities. Yeah? So let's get into Fusion and we'll start messing around with it. I think the easiest way to go about, I'll just leave that sketch up as inspiration. The easiest way to go about doing something like this is going to be to start with the kabuki mount, and slice it up into its component parts. Like actually save it as a new design and then do some plane cuts, which is, I will fully admit, lazy design. Like I should go back through the parametrics and like do it all correctly and accurately. But I think we're just gonna slice and dice, chop and screw the existing design as much as we can. So let's do a quick save as. We'll call this kabuki bearing. I mean, bearing is so far a fairly inaccurate term. Yeah, as Thomas says, like I could use like a 608 bearing or a skateboard bearing or something like that. But no, we're gonna go with just the friction fits, you know, the slippery design. So looking here, let me roll to the end of my timeline and see. Chris says, what about dropping into a new drawing and projecting the needed points? So I totally could. The trick is, I will say, Chris, actually, you know, maybe there is a way to make that work. The most tricky part of the whole operation is that this hole is an incredibly specific shape. And I need to preserve basically the shape of this hole. Although now that I say it out loud, let me see if I can find, in one of these shapes, I used to have basically a shape that was constructed exactly to fit this hole, using the body creation tools, the boundary fill. I said basically, give me a body that represents the void inside of this hole space. I'm trying to remember which body that actually, which component that actually lives inside of here. No, it's not in hanging hardware. That's old. Does it live in servo mount mods? No. Does it live in servo holder scratch? Does it live in Pro? It's not in the PCB components. It would be in. Oh, maybe it's in case bottom. Yeah, here we go. Okay, so in each of these components, in each of these bodies, I think I have a shape called hole shape. Yeah, So that hole shape should be just if I turn off some of the other bodies here, Let's turn off servo holder. Let's turn off servo mount. Let's turn off the other bodies. Yeah, so this body represents the hole that I need to recreate. And really, beyond that, everything else is gravy. So I think what I would do, Chris, is basically take this body shape and put it into a new drawing and start from there. And maybe that's the cleaner way to go, right? Because part of the reason I was preserving, well, God, all of this other geometry was because it had a lot of useful other parameters built into it, but maybe that's unnecessary. Let's give it a try. Let's take, basically, okay, so I want to move, copy. Can I just copy a body as given into a new into like a new design? Copy, and let's create a new component. Always good to work inside of a component. I guess I should save this first. This will be Kabuki bearing from scratch. Yeah, that was a good point. Yeah, bearing is really generous. It really is more of a a bushing or a pivot point, maybe we could call it, or a friction mount pipe support. So we will call this hole shape. And can I just paste my body in here? Let's find out. Copy. Can I copy and paste bodies straight from one design to another? I don't think I can. I think my best bet is to take this ML hole mount design, bring it in, and delete some stuff from it. And that hole mount design is actually based on the original like like fidget cube, this geared fidget cube essentially that I showed off a few weeks ago, whose design I have ripped off to not have to redo all of the work of coming up with this snap fit design. Right, so here is this like you know, geared, painted 3D printed mechanism, which is a lot of fun. And each of these 8 corners is held in with this double-sided snap fit peg. And I'm stealing that design to do this with. Chris makes a point. Do I need to have a bodies folder to paste into? I don't know. Let's see. So if I were to, let's just create a shape, right? So I have I guess I could try, do I paste it directly into this component? Or origin? Let's see. Let's just create a dummy body, create a box form, just to have a body there. Can I paste here? No. Can I paste in the global component? No. Yeah, something I've never tried to do before is just copy and paste, just Control V. Yeah, nothing doing there, Thomas. It's a good thought. Oops, can I use the context menu? Undo, redo, move, copy. Here, let's make sure it's copying successfully. If I do copy in the original document and just hit Control V, I do get a copy. So it's letting me copy within this document, but not outside of it. So, but thankfully, I think I have somewhere, let's see, where is that ML hole component? I'll just use my search function. ML hole mount, there it is, ML hole mount. So I'm just gonna bring that whole shape in, and it's gonna come in as linked, and I'm gonna unlink it in a second here. So let's see, so let's start with the 2 mounting holes on 44mm centers. So let's rotate this around, because I want to think of this as being right side up on a truss, so we'd have 2 hooks sticking up this way, hanging up, and then 1 hanging down. So we'll bring that in. We will break its link, and then we're gonna delete a bunch of stuff that's unnecessary out of this part. Yeah, it's true, Tommy, like the exact mechanics, especially when you get to copying and pasting between different projects and components within the same project, I'm with you. I don't really get it. So I have some other sketches in here now, which I don't know. Maybe I do need. Let's see, what's in this new plate section? So that was the that was the filler shape, the sort of surrounding shape that I used. I'm going to hold on to that. So now I have these two bodies to work with. I have one that's just the shape of the hole that I need to preserve, and then I actually have already this body shape which contains that hole. So that'll be kind of a useful thing to work with. In fact, why don't we just duplicate that? We'll just do a rectangular pattern on, I guess, this body, and we will stretch it out. We'll pick a direction. About this way. I only need 2 of them, thank you very much. And their distance is going to be 44. 44 has 4s in it. Millimeters on center and 1 in the other direction, and hit OK. So that's my 2 hanging holes. Chris says, create components from bodies if needed. Right-click on component. Right-click on browser root of new design. Oh, so you can only paste a component? Chris, is that what I'm understanding? I think this is going to be a working method for now, but just so we all learn something. So I have this hole mount component. It has this hole shape component inside of it. Chris says old info. Well, let's give it a try. I'll say create components from bodies. So now I have this hole shape component. Right-click on component. Copy. Right-click in browser of new design. Click paste. I don't think I have a paste. Paste new. Paste new. Oh, that worked. Hey, look at that. Yeah, so the answer turned out to be, thank you, Chris. No, so that does work, right? The answer turned out to be, rather than being able to actually copy and paste just a body, if you create it, if you transform it by right-clicking and hitting new component, you can copy and paste that component into a new design. Cool. Well, I learned a thing today. Thank you, Chris. We've sort of done like the inverse, right? Rather than making a component out of just that body and then bringing it in, we've brought the whole encapsulating component in, and then we're just going to use that one body. So, but either way, it sort of got us where we were going. And to further this process, I'm going to take this whole design. I'm going to move copy it. We'll move, oops, we're going to want to create a copy. Create copy. We'll center this between these two objects. We'll do a, and I'm being a bad non-parametric boy, right? I could do this with a sketch that had a centered constraint between the two of these, but I'm just going to make it 22 millimeters on center. I'm going to rotate it. I'd really like to rotate it around a point that left it on center line. Let's do a rotate around that center point. Oops, no, but it's only going to give me that axis of rotation, huh? Well, I could do this in free rotate. We'll do a free move. So we'll rotate 180, and then we're going to need to make sure it's lined up on center again. So I think the easiest way is going to be to do a point-to-point move from the center of one to the center of the other. Yeah, and then I'll just do a free move back 22 millimeters back to the center again. There we go. And then I can move it up. There we go. Okay, so now, okay, so here's a thing we're going to have to contend with, right? So that's a decent place to start, right? So I'll have 3 hooks, 2 going up, 1 going down, but the vertical placement of this hole is actually constrained because the dimensions of my kabuki mount for the servo are already defined. And I could take this dimension off the actual drawing, and I guess I will in a second here, but just to show you the challenge. Yeah. Try and get this locked into this bit of truss. There we go. Right, so I have this bit of truss, and I need this other hook to be placed in such a way that this shaft is resting on the crook of that hook. So essentially, I need to put the hole which holds this hook in the right vertical orientation so that it holds the hook here. If that hook is too high, right, my shaft will be off this way. If it's too low, it'll be off this way. So yes, we're going to have to do a little bit of math. And I guess the let's think about this. I'm trying to figure out if there's a way to do this that doesn't involve taking any measurements off of the hook itself, because in some ways the dimensions of the hook are going to cancel out. So because if oh no, they're going to be self-reinforcing. I was thinking like if this part of the hook were longer, then this surface, if you will, this part of the mount would be lower, and so the part of the hole that held this hook would actually have to be higher up. So it's positive feedback in a way, and it's really going to be dependent on the size of this hook. Now, one thing I could do, frankly, is just like hold the hook here and measure it. In fact, let's start with that just as like a, like rough magnitude issue. And what am I going to measure from? I guess I'm going to measure to this point, which is approximately the bottom of the hole. And I'm just going to eyeball what it is from the servo to that point. Just as I'm not going to actually use this measurement, but I want to know like roughly what it is, so that when we get an actual measurement answer, we'll know that it's sane or it's totally off the mark. So I make that about 36, 37 millimeters, right? So that's the ballpark we're looking for, from the center of this servo to that point. So what I really need is the distance from the bottom of that hook shape to the point, and I'm just going to measure. So as printed, that is 39, call it 39.5 millimeters. Don't you have a drawing with this info? I do, Chris. I totally do. But, yeah, it's right here in front of me. So 39.5 millimeters up from this servo point. And let's take a drawing, let's take a measurement on the drawing from the center line of this servo to this flat surface. So looked at in the drawing here. What I want to know is, I gotta turn back on all those bodies that I turned off. Let's see, what are you bodies? This bodies, yes, that's a good body. Yes, case bottom, yes. Okay, so what I want is from the center line of this servo, let's get everything back in context here, to this plane. And let's see if it will let me do that in a not painful way. So I really want, I guess I could take, how about the center line of, no, I might need to put a sketch on this face and make a point out of it. That's probably not, this is not necessarily the cleanest way, but I think it will be all right. So, yeah, of course this is not actually a circle, although it is going to let me create a center point in the rear of this here. Point, oops, undo, create, point. There we go. All right, finish sketch. Yeah, could you center the blue face? It looks like, so the bottom profile of this hole is circular, it seems. Let's see, what is that? Is that actually concentric? Or no, it's the countersinking on this. Chris, you're making me doubt myself, which is good, right? Like, that's... I was gonna say that's what I pay you people for. That's the opposite of what is happening here, for sure. Let's just do a couple of quick... yeah, so I believe that is center line 1, 2, 3, 1, 2, 3. Yeah, so that is the center point of this gear. So let's now inspect. We'll measure from that point to this face. That is 22, I know it's hidden there, and you probably can't read it anyway. It's 22.65 millimeters. And we said that this distance from hook to tip was 39.5 millimeters. So, I'm just gonna write these down. 22.65, 39.5. So we need the tip of this hook to be the difference between those two numbers up from this surface, or in other words, just a little under 17 millimeters. Yeah, Yeah, no, listen, I would, for all of the help and kindness and encouragement and love that y'all show me, you should get paid. It won't be by me, but you should get paid. So here's what I'm going to do. I'm going to create an offset plane from this face. Ooh, well, I could show you that face if you really wanted to see, you know, the drafting. And it's going to be 39.5 minus 22.65 millimeters up from this face. And then on that face, we'll create a new sketch, and we will project this surface onto that face. We'll put a new point right in the center there, and we'll just do a real simple point-to-point move. Let's see, where is this body? It's here. We'll move copy, point to point. We'll take the top of that guy, and we'll move it to that guy. Right, so that's going to give us our... actually, I know it's not that point. It's the interior point here. So I'm going to do a move copy, not with that outer point, with the point which represents the interior of the whole. We'll do this body, point to point, take the inside point here, and move it to that point. So that the outside's going to be a little bit higher. I think that's right. You know what's wild about a lot of this is, so I was doing some of the design work for this hook. You know, we did this hook together basically on a stream about a month ago, and then I afterward did some refinements, and I thickened up this profile, right? I sort of added this larger hook section. I don't actually have the Fusion file for this exact hook. Somewhere in moving between like the 3 different computers I ended up working on this on, and I lost this Fusion file. I think it was one of those situations where I had it open on one computer, then I logged into my Autodesk account on a different computer, and it forced the other session to, like, I think suspend, but not close, and then that computer ultimately, like, was shut down without allowing the process to resume, and so it didn't actually save that work. In any case, this I have as an STL. I don't have it as a Fusion drawing, which is super unfortunate. But like that said, I believe, have it as an STL. So maybe we pull in some copies of that into this just to, you know, do a little sanity check on the dimensions here. So let's insert a mesh. And I will just pull in, let's see, that's going to be in my Moving Light JG, I think. Large LED mounts, no. Pin hook, what is that called? Pin hook 096. Yeah, there it is. Yeah, Chris, it's super bummer. I mean, like, ultimately it's not the worst because the bottom half of this, you'll recall, is an STL that I imported from another design previously. And this profile, like, I could relatively easily recreate. It's just it's more silly than anything else. So let us, well, and this is just for sanity checking. I'm gonna move point to point. Can I move from the point of this mesh? Origin point? No, I can't. I'd have to convert this to a B rep. Ugh. Well, that's super unfortunate. Let's see here. You know what? For the sake of a sanity check, I think we actually will do well enough because these 2 mounts are centered at the origin. We'll be able to just eyeball it from here. And then we'll just print it and see how it goes, right? That's the joy of this iterative design is I can just print a copy of this and we'll see how it do. I gotta insert another copy of this mesh. Can I not just duplicate this mesh? Apparently not. Oh, I could create, here, let's create components from bodies. This one, oh, can't do that with a mesh body. Just have one of my employees recreate it? Yeah, I'll farm that out to the process and design revision department. You know, that'll be just great. Wow, pull this down here, 44, great. And then, well, that's not how any of that works. And then we will insert a mesh, same mesh, rotate and move. Just to try and catch any really absurd errors that I've made in my process here. Hopefully are not too many. So something like that is the ultimate arrangement of these things. Well, I'm seeing one minor issue already. Well, actually, it's not a huge issue, but looking at this, right, if we wanted to have all three of these points on a single line of truss, right, so the, or a single pipe, let's say, so the kabuki line would be here, would be running sort of left-right across the screen here. It would be hanging, we'd be looking right down the pipe at the moment, and given where these hooks are for, like where the holders are for these hooks, we wouldn't actually be able to sort of linearly get the pipe in. Like we wouldn't be able to snap it in from this side, which might be a little bit unfortunate. Although I guess what we would do in that case is, because it does look like there's room for the pipe to actually exist here. Yeah, one thing we could do, Chris, is rotate this hook 90 degrees and this would span the truss. Or we could place the pipe in it and then snap the hook in place, right? Because it's just a snap hook. That wouldn't be too bad. You're rotated. I'm rotated? What's rotated? Who's rotated? I'm rotated? What's rotated? Chris, you're scaring me. Let's see. So, yeah, so if this is... Yeah, so like one option, right, would be here. Oh, I see. Yes, could just do it rotated. You're yes. Okay, I think I see what's going on now. So another question is how to make this printable. And, ooh, what's happening in here? Show me this in the browser. Turn off hole shape. There we go. Wouldn't the bottom hook be rotated 90 degrees? Oh, I see, Chris. Yes. So two possible options here, right? Here, let me illustrate this in the table. Thinking of this again as you know, basically a similar slice of our mechanism here. So if this is, in this case, let's say this is our servo and this will represent our mount. We could either, like, so what you're saying is, like, we could mount the clips across the truss here, right? And then our new clip hangs down here, and that's our attachment point, which would totally work. I was just thinking through the possibilities of the other thing which this mechanism is designed to do is, with a rearrangement of the clamps, put the servo actually collinear, or I guess underneath a singular member of the truss, or, you know, a pipe equivalently, right? And would this same mount be able to function in that kind of rotated 90 degrees orientation? And I think that it would. And again, just using this other servo mount for illustrative purposes, right? With these here, that other clip, and I really should just, I should have pulled more of these clips out to play with, but I'll do that in a second. Now here's the thing. Eyeballing this, it doesn't look to me like the center line, right? Because this, you know, this nobule, this clicky point, this surrounding for where this hook clips in, is going to be the same as in the design we've just been working on, right? They are the same idea. Basically, if we took all we did literally was take these two nobules, isolate them from the rest of this, and add one more nobule in the center upside down. That's all we've done so far. And eyeballing this, I don't think that the bottom of this nobule, like, is in the way of center line here. Oh, although that was not our problem. That was like, that is also true here, right? We have clearance under this nobule. The issue is like slipping the pipe in here, but we could always just like slip the pipe in and then click this into place. So I think that's okay. Hopefully that was not well, I was gonna say, hopefully that wasn't a long-winded explanation. A long-winded explanation is exactly what it was, but hopefully you You bore with me for a time, and I thank you for it. As far as the printability of this, so I need the space, you know, basically the space that would be occupied by any of these clamp pieces to be clear. So I can't have a contiguous section between these two. I think it's going to have to sort of come up to this one and down to the other one in some kind of tasteful way. And then maybe we'll flatten out one or more of these sides just to give us a nice flat printing surface to print on. So let's do that first. Let us start with a tangent plane on this side, let's say. 0 degrees, that's fine. We'll put a new sketch on that layer, and then I'm just going to project all 3 of these bodies onto it. And then one by one, we will, oops, not sketch, we will extrude to object and join if it'll let me. Kind of let me. What is, let's see. Show me this in the browser. What's happened here? So yeah, so I didn't get a nice clean join there, which is a little bit odd. I think it's going to export to slice just fine, but it's a little bit strange, huh? Let's try this one. Distance, extrude to object. This one, yeah, again, it's not wanting to join sort of natively, which is odd because it's, whoa. Oh, it's having trouble with this surface. That's unfortunate. Well, let's go about it a different way. Let us, yeah, Thomas, I suppose to put a finer point on it, yeah, I didn't really get it to join even a little bit. Let's project those. Now, let's see if I do this in 2 parts, right? So we'll do one projection from this to object, this one, join. Okay, so that seems to have worked. This is one now contiguous body. Show me this in the browser. Not that. Yeah, so that's one body. And now if I do an extrude here to object and join. Yeah, okay, so it's just going to be a 2-step process here. So we'll do that. We will come back into our sketch, and we'll just do the same thing for these other 2 bodies. We'll extrude to these 2 surfaces separately. That one and that one. Okay. We'll extrude that surface to this body and join. We'll extrude that surface to the cone and join. We'll extrude this body to this surface and join, and we'll extend this to this body and join. So Chris, the extend types, right? If I do extend through, it will go until basically the body stops, as opposed to where the body starts, which is what I want in this case. All right, so let us turn this sketch off. And now I have this flat shape, and I'm going to actually turn my mesh bodies back on for a second. Not that they're particularly accurately placed, but just to keep myself honest as to what the shape of this thing is. And actually what I might just do is just do a little like beep boop, like a little zigzag deep doot between these 2. I think that's okay. I don't think I'm going to run into any issues there. I'll put a sketch on this face, and we'll just project in both of the other shapes. And we'll do like a 1 and a 2 and a 3 and a 4. Something like that. Let's do a plane at angle through an arbitrary point here. And we'll just do an extrude of those 2 faces to that plane and join everything together. All right, so there is like a really rough, like, so it prints with this flat side on the print bed, right? And it's a really, so one thing I'm seeing is like, I wish there was a way, I mean, I guess I could print it in this orientation with some supports. Yeah, I mean, listen, there's certainly stylistic choices to be made here that we haven't gotten to yet. But just as like a real rough, idea of shape, I think that these whole shapes are going to print better if they are printed vertically, either bottom up or top down. So I think I actually want to print it in this orientation with these on the bed and printing up, which means that all of this additional like extrusion flattening work might have been for naught. If I were to do this again, there's actually a different way I would go about this entirely, rather than starting with the sort of arbitrary conical shape and building back out to something square. I would go back in and take that that whole shape and just put those three things where I wanted them, like where I wanted the holes to be, and then build the shape around it. Oops. And then cut those out at the end and call it done. Yeah, because this is going to be kind of a silly thing to ultimately have done, but that's all right. Let's do another tangent plane on this side. We'll create a new sketch on that side. We will... Where's my other sketch? Must be in here. Yes, and we will just do the same thing on the other side. Project our bodies in. Project our individual features in. Finish, and once again, so ultimately I'm going to take this nice rounded shape that I made and spend a lot of operations to make them back into like a square. Like I say, I'm fully aware that this is not the cleanest or most parametric way to do any of this, but for the sake of getting a working demo going, for the sake of tonight, I think that will be just fine. Object and join. All right, and then we're going to roll history marker to the end. What has crashed here? Ah, right, that face is gone. Oh, that line is gone. Let's do that face. And there we go. There's our chonky shape. Our chonky truss hanger. Well, let's clean. Let's see. So this is going to print in this orientation. So why don't we thicken this out a little bit here? We're just going to, on the original sketch, we'll come back in here and we'll strike a line. Oops. Just parallel to this bottom face, and parallel to there, and parallel to there, and we're just gonna square off. Actually, you know what? Let's do this as a separate sketch. Ooh, Chris has warmth the printer. That's a good idea. Let's get that home. Preheat PLA. Thank you. Here, actually, we don't need to do this on both sides. We'll do this on one side, and we'll mirror it. And actually, I'm going to do it after the fact here in a separate sketch, so I can use this angle and continue it on. And we'll make this line collinear to that line. Let's see. Is that what I want? No, I don't think so. Let's take this line, bring it out here. We'll take this line and bring it over and make it horizontal. And we'll make this coincident. We're just going to square off these corners a little bit, give ourselves a little bit of an area, more area to have on the print bed, just so we don't run into adhesion issues anywhere. All right, so put a mirror line down the center line of that, and we will mirror this line across. And it is going to make this shape somewhat chunkier, but I think avoiding the adhesion issues is going to be worth it. I'll project that in and bring another mirror line down, and then we'll just mirror these shapes across center line. Mirror, 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 done. Finish sketch, and I think I should have a plane already in the right place to do this. Let's see here. Yes, and we'll just extrude 1, 2. What? What? Oh, it was not closed profiles? Ah, yes, well, that would explain it. Let's do that. That's closed. This is not. We'll just close that up. And we'll extrude 1, 2, 3, 4. Distance to this plane, join. Uh-oh. Something is still... Something in this did not join properly. Where's the step where that should have joined? I think it's this extrude. Extrude, join. Should have joined to both of these, and I'm a little bit worried that it's not. Like, these should be contiguous shapes. Let's see. Making the pyramids. Yeah, there is something like weirdly occult here, Chris, about like just like what's happening. Oh well, I don't want to be in the sheet metal tools. Can I join these things together? Join. Yes. And now it's a solid body. Okay. So in theory, that's our puffin. Should really be using more circles today after Pi Day. You're not wrong, Chris. I'm really bucking the Pi Day trend. Well, here, just to make things a little bit better, why don't I, I'll do some fillets, some little slices of pie in our design, just to tidy things up a little bit here. Let's do these inner curves. Go. Let's do these outer edges, and then we'll get this thing printing. 2, 3, 4, 5. Let's just do a nice little like 1 millimeter. Yep. Ooh, and in fact, let's do these sides as well. And that side. That's not bad. Do a radius of pi over 2. Sure, why not? Pi will come in as a constant, I think. There we go. Pi divided by 2. There we go. There's our Pi Day celebration. Those corners are now filled with a radius of pi over 2. For Chris. I was going to say for all the nerds out there, but Chris, that's for you. All right, let's get this thing on the printer. So I'm just going to, as always, save as STL, save it out to a file. Let's see. My organizational system here has fallen apart just a little bit as my project and the truss modifications and the Kabuki project and the Demilight project are all kind of merging into each other, right? Like, does this part belong with Demilight stuff? Not exactly, but it does use the Demilight hook. Does it belong with the Kabuki stuff? I mean, certainly. But it also is kind of a mod for the D3D truss. So what's up with that? Has an AOL logo look to it, says Chris. That's fair. I can't deny that. I'll bring that in, get it in the right orientation. Let's do my favorite new thing, which I think I raved about last time, which is variable layer height. We'll do an adaptive and a smooth and slice now. And that's going to be a 56-minute print. Not bad for a print of this size. Let me just, for curiosity's sake, let's go back and just make this a straight up 20 millimeter print. Oops. Non-adaptive. What's our print time on that? Also 56 minutes. So we're not losing anything by doing the adaptive layer height. Well, that's good. We'll do adaptive, we'll do smooth. Yeah, I guess there's not that many layers at a lower layer height, and then most of the time it's going to be in that big draft 0.25 millimeter layer height. Let's do a quick looky-loo. I think this is all going to print fine, as is. Well, all the more reason to, like, let's get it on the printer and going. So this is going to be Kabuki hanger. Yeah, save. Let me grab ye olde flash drive. Pop that bad boy in there, and we will find that print in ye olde file system, in Kabuki, and Kabuki hanger. Copy it. More speed over quality, says Chris. Yeah, I mean, the fact that I didn't save any time at all going from a straight 0.2 millimeter print to an adaptive, like it's not doing that much adaptive layering except in some of this top area here, which I don't hate. I mean, if we go more towards speed and slice, let's see if we save anything. 57 minutes. So not a huge savings there. I think we're just going to get it on the printer and get it going. There's gosh, talk about things that I wish I could remember. I read a really fascinating article once that had a principle that was named after somebody. It was like the Simon's principle or Helen's principle that said that there are some situations. Here, I want to show you something a little bit more interesting. Like honestly, like the back of my shirt. Isn't that fun? That there are some situations where you can only achieve the optimal solution in terms of time for a thing, right? And this is applied to like business processes, like studying like what's the fastest way to load a container ship, or a better example, 1,000 trucks of materials show up at the dock, and you want to get those materials loaded according to certain parameters in the least amount of time. And that time includes the time it will take to run through your algorithm for determining what the shortest loading time is. And this principle, which I cannot for the life of me remember what it was called. Let's call it Helen's principle, whoever Helen is. Helen's principle was that there are situations, and they come up very frequently, that the only way to achieve the optimal time is to run a suboptimal algorithm, right? That the trade-off in additional benefit you get in terms of taking less time to do the actual task are outweighed by the time, or for other situations, the resources or the computational power or how many CPU hours you're using to find that optimal solution. And there was a sort of a mathematical demonstration of like the phenomena under which this was occur. And I think about this fairly often for a thing that I can't remember the name of, because this sounds similar to Parkinson's law. Ooh, Chris, I don't know Parkinson's law. Can you drop like the Wikipedia one-liner in the chat for us? The Parkinson's law, the work expands to fill the time allotted. Ooh, yeah, so kind of the inverse, right? Like if you have X time, the task will take X time. This is kind of like the situation in optimization, where let's say you had an algorithm in this hypothetical example of loading a container ship where, if you let my algorithm run for an hour, it will find the fastest way to load the container ship that will save you 20 minutes over the algorithm that takes 5 minutes to run, right? And so it is not necessarily always true that using the algorithm that gives you the most optimal process is actually the most optimal solution. And I think about this in terms of, God goodness knows these days when we're all in, Zoom meetings all the time, it's like, okay, if it takes, 10 people, on a Zoom meeting, it takes hours to decide nothing. But let's say it takes 10 people an hour to come up with an optimal solution to this thing. Or it could have taken 2 people an hour to come up with a slightly less optimal solution. Is the value of that, the difference between that slightly less optimal solution and the optimal solution, greater than 8 person hours of meeting time? Because if it's not, what you've actually done is decrease your output or your productivity by having this process. That sort of makes sense? I don't know. Way off topic from kabuki drops, but something I think about a lot in sort of like process management is factoring in your meeting, planning, strategizing time as a cost of your solution. Yeah, anyway, that's neither here nor there. Let us, let's do something else for the next, I don't know, 54 minutes until our kabuki is ready to test. I think what we should probably spend that on is figuring out how we are going to actually attach a curtain or some pegs to this shaft. I probably should also, I hope I still have the shaft couplers handy that we printed last time. I haven't thought about those in a while. Yeah, I guess we haven't actually thought about how we would attach the ultimate coupler to our ultimate shaft, and whether we're going to use something like a 3/16 brass shaft or just move ahead with 3D printing the whole thing. So we may or may not be able to do an actual full test of this tonight. But it would be awfully fun to at least have this thing like mounted and in motion. So let's work toward that. Take this old horn off. Let's make it so this will be our control servo for the evening. We set this back up on our test truss. And I think, I mean, I like the idea of having that mount that we designed that can be in either orientation. But I think for stability, that's not right. I want this to be like that. So that means that these hooks have to be there, and we'll clamp them like so. Because it almost looks like that 3D print would fit inside the brass. Ooh, it almost does. If this was a true 1/4" shaft, I bet it would. I mean, we could do some, we could like, for the sake of experimentation, I'm perfectly happy like gluing this for tonight. Might be the way to go. Let us attach our, what did we call this last week? The Thomas bearing, I think. Courtesy of Thomas P. I think that's a perfectly suitable name for this thing and honors its heritage. So we'll put the Thomas bearing, Thomas coupler. We'll put the Thomas coupler on the Demilight Kabuki mount so that it mounts to the D3D truss. And all of a sudden, we've got a little ecosystem of parts going, which is delightful. Chris says the employees demand a second 3D printer in the shop. I mean, listen, I'm all for it. I suspect that some of the other people that I'm co-located with in this facility might have opinions about how we were allocating shop space. So it might need to be a slightly delayed expenditure. But the other CEO, let's be clear, the CEO, I might be the CTO of this arrangement. That's not fair. We're a good partnership. I don't love the like, well, the wife's in charge. No, we're a great team. But I will also be honest. She's the organized one. I'm the nerdier one. So if anyone was going to be CEO, it'd be her. Or the shareholders are fools. Yeah. So there's our Thomas coupler. There's the output shaft. So yeah. So I think honestly, we'll probably I'm just gonna glue this for tonight, just so we have something to play with. And then, but this is also, so like this is a part that we did a really easy design on. I could almost, if this was a little bit thicker, I could drill out the center here for tonight to play with. The ultimate design, I think, is probably just to like make this a slightly hollow part and insert this in as a slip fit, either with a set screw or a little bit of glue, and then that just couples on. That'd be pretty cool. So yeah, so for the sake of tonight, let me see. I've got my, gosh, I know I've raved about it before, but I really love some of the shop improvements that have happened in the past few months, including the Wall O most useful tools, which continues to change and adjust and expand. But like one of the things I love having close to hand is a hot glue gun and some sticky tack. Just like I need to bodge something together. I want to do it quick. I don't care about it being permanent, and I want it to take less than 5 minutes. A glue gun or sticky, or for really temporary stuff, sticky tack are like my absolute go-to tools. Now, what I have run out of, unfortunately, is like readily accessible plugs. I have so many power strips, and all of them are occupied by things, but I think this one is ancillary. And unplug the 12-volt power supply that powers my chair warmer and massager, because yes, I'm bougie. Chris says, what prevents the Thomas coupler from detaching from itself? Currently, nothing. Oh, you know what that also was powering? Scared me for a second there, Chris. Tip this up a little bit. The 12-volt power supply, I forgot, is not only my chair massager at this point, but is also the lights above my 3D printer, because they're also 12-volt. But the printer itself, of course, is not 12-volt. It's on its own circuit, and it's on its own UPS, specifically to ride through accidental power outages. So we'd have a little bit of leeway there. Yeah, so Chris, nothing is currently preventing the Thomas coupler from decoupling from itself. That will be a problem to solve. I mean, tonight what's going to prevent it is more hot glue, I suspect. But maybe it is. Well, let's think about that, because we have, a little bit of time. Let me take a peek at what the end time is of that coupler print. It is, well, I have not changed the clock on my 3D printer yet. 9:01 local time will be our printing out. Did I fix the screw spacing and offset? I did, yes. Although I don't know if I fixed it in the same way that you did, Thomas. I ended up sort of like redoing that sketch and just putting a little clearance there, but it seems to have worked just fine. Yeah, that coupler is quite good. It just doesn't lock at this point. Let's see, what's going to be... I guess, well, you know what I could do is... and there is now don't, listen, don't get too excited. There's a slight fire risk involved with what I'm about to say. But what I could do is get the brass of this rod hot and then melt it slightly into this plastic. And that would give it some additional mechanical rigidity, which I quite like. And I think that would be quite a fun idea. So let's get ourselves set up to play with that, I think. Now, a couple ways I could do that. I could do it with a heat gun. I'm hoping that just like the little heat of my lighter will be enough. If not, we'll go to stronger sources. We could put the soldering iron on it. We could put the heat gun on it. Wow, there's like crunk on this lighter from previous disastrous experiments. Well, I guess first things first, let's think about safety. Safety is good. We'll put some safety glasses on. Let's see. Does someone say fire? Yeah. Yes, I know. The magic words. Let's see. So we'll want something to hold this as it gets hot. I'm going to leave the hot glue gun heating up for now, just off to the side, because I think we may have use for it yet. And yeah, I thought I might summon Dave and others back in here with that. We'll just get these sort of gently. What I really need, so I was gonna say I would like some soft jaws on this, so I don't risk like. Not that this is a precious piece of brass, but for good practice, I'm just gonna wrap this brass in a little bit of this marine vinyl, and we'll hold it out here at the far end. Let's tighten that up just a little bit. All right, so there's that. And I really like something to hold this with, because this operation is going to basically heat this up and then stick this onto here and try and get them concentric. Yeah. I'll tell you what, before we do this for real, let's take, here, I have some scraps here from our experiments last week. Is that the remnants of last week's curtain? Yeah, very much so it is. Now it's an experiment. Let's try this melting idea on, this was one of our other snap couplers that we were playing with last week that broke. So now it's just scrap plastic. So let's see if this idea works. It's a pretty dinky flame when you get right down to it. We'll just see. I have no idea of how long I should be waiting to do this, but So I did get, I got a little tiny impression there, not the like largely melting in effect that I was hoping for. I almost wonder if the soldering iron would be a better tool for this, that I could apply like a consistent like 60 watts of heat. That went better. Yeah, so I got some decent, I mean, only probably a 1/16 of an inch of penetration on that, but that's better than just sitting on the surface. Because I would, again, this is all, none of this is going to be the long-term solution. The long-term solution is going to be a 3D print thing, but I'm trying to get a thing working by, 41 minutes from now when the thing comes off the printer. Let's try this one more time. Just kind of perfect the method. So we'll really just scorch this guy up. Scorch this guy up here. Get him nice and hot. And then right in there. In fact, can I apply more heat? Yes, I can. Haha, look, I almost pushed all the way through. So the trick was to get it hot, get it started, and then apply more lighter to it while continuing to press in. So that seems like a dumb but plausible strategy. And now that's really quite in there. That's quite cool. So to make that work, I will need something to hold this in place. Let me see if I have a little... I wonder... This may not hold exactly like I want, but this is my PCB vise, which is spring-loaded. See if I can get it to grip this cylindrical form here. We'll just loosen the springy parts up and then bring the bottom in so it's nice and clamped in place. And we'll tighten that adjustment and leave that springy in there. So the idea will be zoom out. Probably some of this will be obscured by myself, because I'm not going to be particularly paying attention to how it looks on the camera. I'm more going to be paying attention to how it looks in the melty plastic part of the experiment. But the idea will be to heat this up, start pushing it in there, and then apply lighter consistently to the top portion of the rod here. I'll tell you what, let's see. Because this is going to want to autofocus on not the interesting parts, let me see if I can get this to focus down on where the meltiness is going to be. Ah, yes, Dave, this vise. Yes, I love this vise as well. Let's see. So, you know where you could find this vise, Dave, is if you go to jeff.glass/blog. About a year ago, I did a big ol' write-up of all of my bench tools at the time, and I definitely have this listed there. It's just an Amazon product, so it wasn't terribly hard to find. I'm wondering if I can even just start this with this fairly centered already, just so I'm not trying to like heat it up separately and get it over here real quick. So I'm gonna kind of brace that vise, get that centered. You know what would be really quite good is if I have... Oh, yeah, I could, Dave, I could certainly send you this vise if I wasn't constantly using it to do dumb things like this. I'm gonna look in a new place under the desk where like the big tools are to see if I have readily available just like a decent glove, which I don't have around very much anymore. Actually, here, let me see. I've got one back here. I was thinking it'd be nice if I could get my hand close to that rod just to be able to help guide it in place a little bit. I have 2 sets of fingerless gloves back here accessible, but that's kind of the opposite of what I want. So let's see. Seeing as necessity is the mother of invention, we'll use a little of this vinyl again. Although I'm not going to have actually, you know what? I'm not going to have a hand free to put my hand here because that hand's going to be holding the lighter. Well, shall we give it a try? Maybe before we... Here's a sentence that sounded a lot better in my head. Maybe before we turn the lighter on and start melting these plastic things together, maybe it's time for a sip of beer. Oh yeah. All right, so where were we? Here we were. Yeah, this could go very poorly. But we gotta try. All right. Here, let's get this end quite warm. Oop. This is what I was afraid of. That piece just slipped down in the vise there. Trying to keep these two parts coaxial. That's going, I would say, okay. All right, well, it was going okay. That could be worse. Just gonna heat that back up and bend it back into place. You didn't think this was a metalworking channel. And it's not. So you were right. But that worked out okay. For a kludge, for a one-night experiment, that worked out okay. That's actually not horribly mechanically insecure. We are going to put a dollop of hot glue on that just for good measure. But that actually, as a experiment, as a get the darn thing working in the next 15 minutes kind of a project, that worked pretty well. All right, and now, ooh, it's still quite hot. We'll do just a big blop of glue, mostly to prevent the plastic and the brass from slipping away from each other as best we can. And then we'll just let those cool. Yeah, turn that autofocus back on. Yeah, all right, well that's, I mean, I don't know if it's something yet. I guess we'll find out, but it's kind of like something. We'll just let that cool off to the side for a moment. And now we'll take a victory sip. Thank you, Chris. Thank you, Chris. Saving the day because I was muted. Oh, I've made these. These are just slightly not collinear. But that's okay because I have a lighter. Alrighty here. We'll just remelt that hot glue a little bit, soften up that plastic joint. We'll just massage that back into place. We could also redo this alignment once we have the other support in place. You know, basically use that support to create that alignment. Well, that's quite satisfying. So that's going to be quite a nice joint there. Why don't we get a controller prepped so that when that print is done, we can actually, you know, spin this thing at least once tonight. I think I'd rather work on that rather than, rather than like how the hook's attached to this, because that's going to be another like 3D printed project, I imagine. And I'd rather be able to like test and spin this tonight, and then the hooks can be another thing to do, I suppose. So let's see about a control board. I believe that, this, what are you? Are you a 0.95? You are. And it has the headers on it, which means there's a good chance I've already put the bootloader on this one. So why don't we plug it in and find out? Seems plausible. However, choose a computer, a new version of Arduino. No, I do not want to download a new version of Arduino in the middle of this. We'll just pull up the Demilight 094 code and see if it uploads. I can see, so this is already running the blink sketch, which is not the default behavior of this thing, which means that at some point I at least tried to put the bootloader on it, which is a good sign. Let's see. Writing. Yeah, it's a great sign. I guess I should just set the address for this thing. It's addressed at 4. That's good enough for me. And that means that the servos are going to be 5 and 6 for pan and tilt. So let's use the tilt servo as our kabuki control servo for tonight. I'm going to pull some header pins out as I get the soldering iron heating up. Let's see here. Did I order new RDM parts? No, Chris, I'll be totally honest, I've set that project aside for a little while only because, and that's not fair. It's still an active project. I just haven't had the brain space to think about it. I think I was sharing this last week, and I'd be curious how others are feeling about this too. I mean, I'm sure we're all in different places, you know, in our lives, professionally, with how things are reopening, is what I mean. The museum, as I mentioned, is reopened to the public as of like a week and a half ago, and just the span of projects that we have been taking on have been really, you know, for a lot of the days using up the mental energy that I have to work in a specific style. Like, for example, right now, a cool project I'm working on, and maybe I'll do a little like mini video featurette sometime, just like a little casual cell phone video of this. We are, here, I'll tell you what, I've learned this lesson the hard way. I'm going to solder this first and then tell you about the thing, because soldering the thing and talking about a different thing doesn't always go super duper well. So let me get this solder joint done on this control board, and I can tell you about this thing, which was another circuit board project that I to my surprise, found used up my circuit board creation brain energy, you know, for the past few weeks. It's also, like, I will totally admit, it's absolutely a privilege to be doing all of this hobby stuff, and so, like, if it's, like, I have to get these projects done for work, and they use my brain energy, and it's nice to be able to feel like, oh, this moving light stuff is really super fun, and I like it, but it is just a hobby, so if I'm too exhausted to, but in a specific capacity to work on it, then I just don't work on it, and that's fine. Yeah, Chris, exactly. Like, there's just, sometimes you just run out of headspace to try these things. All right, so there's our little, we're just going to use that header connection. Now, how do I want to get 5 volts to this thing? Can I just run this off of the programmer for tonight? Yeah, I think so. All right, so we got the programmer there. Oh, but I am going to have to put a Phoenix connector on it so I can get DMX to this thing. Ooh, Chris has a new toy at work. Chris, tell us about your new toy while I solder this Phoenix connector on, sticking with my principle of trying not to solder a thing while talking about a different thing. Put those there, and we'll grab the Phoenix connectors out of this bin, which reminds me I do need to order some more, because we are rapidly running down to the end of that supply. Ooh. Oh, here we are. Here's another bag of them. The four position 150 mil Phoenix terminals that I use for this project, which are a nice balance of availability and size. Can't say much until it's... Ooh, another multi-axis machine at work. Look at you, fancy Chris. That'll be fun. Let's see. Let me get this tagged in here. And then we'll just make sure we have a suitable adapter to get DMX into it. Just solder. As usual, we'll solder one joint in place, and then we'll check for alignment. So that's in place. Yes, you can see that's all kind of cattywampus, but that's going to be an easy fix because we only have one joint to reflow. That's much better, and now we'll do the rest of them. I've already forgotten the thing I was going to... Oh, the circuit at work that I was going to tell you about. Yes, let me finish that joint. That's pretty good. Okay, so this project at work that I've been nerding out about this week. So, and I may have talked about this long ago on here, but we've revived this project now. So at the science museum that I work at, right, we have a giant HO scale model train layout that represents the journey from Chicago to Seattle, more or less along the, it's not the Pioneer Zephyr. What's the route that goes that way? I guess it's not all Amtrak, right? Because mostly it's freight trains on this line, although we do have one Amtrak consist that goes around. Anyway, 3 main lines, like 3,000 feet of track, super cool exhibit in 10 different sections. And if you know anything about model trains, and I was a model train, and I guess I still am a model train enthusiast. I was a model train practitioner for a hot moment several years ago, so I had a little bit of familiarity with this idea. But there's basically 2 different ways you can control model train layouts these days. There is sort of the traditional way, which is DC power, and then there's a more modern way called DCC. And the gist of DC power, get a different color. We're gonna go multicolor on this explanation. Let's do it right. We'll do a very simple track layout, right? So let's say you have a track which is just an oval that takes you around in a circle. And ultimately, like, that's all our exhibit is, right? It's multiple lines of track going around in a circle. And let's say these are representing a single train line, and so there's some railroad ties in between each of them, just with 2 tracks going all the way around, right? One way you could have multiple locomotives able to independently traverse this oval at different speeds is with DC block control, right? The DC powered trains essentially literally are just a DC 12-volt motor inside each locomotive. And if you apply a pulse width modulated signal, you're applying less average power to each motor and the train moves slower. If you apply a higher duty cycle on that PWM signal, more power, train moves faster. Some of the older power packs also like we'll do, instead of doing like PWM, we'll just literally do a voltage regulation. Like there's a variac inside there. And so if it's a 12-volt motor and you're running it at 7 volts, less power, probably moving slower, right? So if you just have a single locomotive going around and around, right, you can just hook up this entire track to one controller and put that PWM on that 12-volt signal, or adjust the voltage, and your train moves faster or slower. If you want to have multiple trains, you break your track up into what are called different blocks, and then you control them each individually with their own power source. So, for example, you might have blocks A, B, C, D, and E, just to pick some arbitrary labels. And Chris will say this is 2 rails of the same track, right? And you multiply this times 3 for our layout, but the tracks, at least in our layout, don't interact with each other. So a fairly simple example. So one train, one locomotive would sit, you know, across these 2 rails in our diagram. And you would have a separate power controller hooked up to A, to B, to C, to D, and to E, right? So if you had a train here in block E and you were applying, say, 6 volts to it, it'd be moving fairly slowly. And the train over here in block B could be getting its full 12 volts and could be zipping along quite fast. You know, so that's the DC way of controlling trains, is you're just applying a different voltage at different sections of your track. There's a little bit of fanciness, right? When your train goes from, say, block B to block C, right now, if you're doing some sort of central automated control, your controller needs to be able to, A, recognize that there's a train now in this section, probably figure out what it was that it was the same train in block B and apply the appropriate current or power to that train. And there's all kinds of fancy ways to do that in computer logic these days, none of which we're using at the museum. We'll get to what we're doing there in a second. But that's the basics of it. And so that we are using a DC system with complications in the museum. The other control system, which I'll mention just to nerd out about a little, is what's called DCC. And in DCC, you don't necessarily need these blocks. You basically wire all of your track to a central source of power and communication. Now, in most practical layouts, you do end up having what they call different, I think they call them power districts, just so that, like, if you had a problem with your train in power district E here, for example, it has its own individual power supply and fuse. So you blow the fuse on section E, this section of the track goes dead, but your other sections continue to function, right? So it's not about control, it's just about like fuse and breaker and power management. But what DCC is rather than in a DC system where you are controlling the voltage or the pulse width modulation duty cycle to regulate power, DCC actually sends data over the power line, essentially. So one of your tracks is a ground rail, and the other track has a digital signal which is balanced about ground, right? So something like long pulses mean 1 and short pulses mean 0. That's not how it works. It's a little more complicated than that. But basically, you don't have like 0 is off and 1 is on, because when your voltage was sending a 0, in this case, you'd have no power. You just have different lengths of high and low voltages communicating data. And each of the trains, each of the locomotives, has a decoder in it that's listening to that data and responding accordingly, right? So instead of having to say, okay, block A is going to receive this much current, this much power to move a locomotive, it's going to say, on the rails, okay, locomotive with address 01001, set your speed to 80% power, right? Locomotive with address 10010, set your speed to 60% power. And in this way, right, you can have a centralized controller that's controlling all of the locomotives on your layout without having to break up individual power controllers all over the place. It also, right, so in this situation, right, in a DCC situation, you can have two locomotives come right up next to each other and meet nose to nose in the way that they could never do in a DC block system, right? In a block system, any two locomotives that are in the same block of track are receiving the same amount of power and presumably moving at about the same speed. So DCC, really a super cool system. When the this is all a long way of getting around to the tale I was going to be telling, which is what the hell the circuit was I was working on this week. So we are a DC block system because at the time that this layout was installed, the assessment that was done between the engineers of the museum and the model train consultants that they consulted with, DCC was still fairly new and wasn't necessarily going to be reliable enough for an exhibit that has to run, 8 hours a day, 363 days a year. So we are DC, at least for now, and probably will be for several more years. But it's quite a clever DC system. Yeah, Dave, exactly. It's like DMX and smart lights for railroads, right? Rather than having to have a wire to every locomotive, essentially, and what wire means what locomotive changes, but it's, in a DC system, you have one wire per locomotive. We now have a distributed data system, and the locomotives have addresses. That's a great analogy. We have at the museum, he said, flipping the paper over, is a very clever system of relays that handle things like speed and power and all of the signals automatically. So, and this is, our model train technicians, we have 2 of them, and they're fantastic. And they're both huge train nerds. One of them more so than the other. Yeah, they are great. I had an hour-long conversation on Friday afternoon about the different ways that the different railroads in the United States handle block signaling. I love these guys. But essentially, our signals work just through relay logic, like on a prototypical railroad, in that if this is a mainline track and direction of travel is this way, and there is a locomotive here, going in this direction, presumably, it would see on its standard railroad signals. And now this is actually what we have at the museum. We have a 3-color signal that references each of our blocks is individually signaled, and because there is hardware in the system that detects where each train is, essentially by saying if there's a locomotive here that's moving, it's causing a current to flow in this block, and so it knows there's a locomotive here, right? The way that the blocks work, and it is based on direction of travel, if the block ahead of the signal is entirely clear, the signal will be green. If there is a train in the next block, the signal will be red, and if there's a train 2 blocks ahead, the signal will be yellow. So let me get some let me get some more colors. So if we're looking this way, this signal would be red. Right? It'd be a little in our case, a little tiny red LED will be on, telling the block behind it, hey, there's a train ahead of you. No train should go past this point. This signal would be, you probably can't see that. Oh, that's not awful. Yellow. I want to do yellow, and I'll outline it in black just so we can see a little better. That's all right. Because it means there is a train two blocks ahead, right? So if a train's approaching this signal, it says, okay, the block ahead of you is clear, but after that, you're going to see a red signal. If there's 2 blocks ahead of you that are clear, you get a green signal, right? So I have 2 full blocks that are clear ahead of me. We actually, given this drawing, we don't know what this signal would be showing, right? It won't be a red because presumably there's no train in this block. There could be a train in the block not shown. So this could either be a yellow or a green signal, depending what's happening here. And our model trains at the museum actually cause this signal flow to happen. If there is a train in this block, this signal will indicate red to show that there is a train there. And because of some additional fancy automation and some breaks in the track just here, any train traveling through this yellow block that gets to the end of this will actually stop at the red signal and wait for the signal to clear. Now in this case, right, of course, it's not the little tiny red LED telling the model train to stop. They're both being controlled by the same controller under the hood, the same logic. But the effect is really quite good. Yeah, the lights are all actually correct all over the display. And, okay, I swear I'm going to get to the point of this story, but I've just been nerding out over this display so much. I'll tell you one other thing, and then I will tell you about the circuit that I have been building for this layout, which is a very minor part of all this. We were talking about in a DC system, the amount of power, or either the amount of power, or the voltage, or the PWM duty cycle, which are all different ways of saying the same, achieving the same effect, the speed of the train. All those affect the speed of the locomotive. The controls that run all this, and this is all just, there's no microcontrollers, it's all just relay logic. Yeah, Dave, there's a point. I swear there's a point. We're coming to it eventually. In relay logic, underneath, the speed that these locomotives are run is also connected to the signaling logic to try and keep the trains spaced out evenly from each other. So you can imagine a situation, right, if you have several locomotives in a system. The print doesn't finish for another 13 minutes. If this story takes that long, it's gone horribly awry. If I have, let's use another color. If I have a train here, let's say this is our longest freight train that has like model tractor combines on it and a bunch of intermodal cars and freight trains. For whatever reason, this one is going to be like the slowest train in the layout. If we were running them all at the same power all the time, you can totally imagine a situation where all of the trains would slowly, over the course of an hour, would back up behind the slowest train, right? This one's chugging along at 10 centimeters a second, and everything else can go faster, but it's backing up at these signals constantly. So what the system does is modulate the amount of power going to each block that has a train in it based on the signal conditions in that block. So for a train in a block, let's say this has a green signal ahead of it, right? There's no train in this block or in the next block. Maybe we'll draw that in here. right? A wide open field in front of it is going to get 100% power. That train's going to go as fast as it can, or as fast as the locomotive will allow it to. And really, when I say as fast as possible, there's a set maximum voltage, which I don't think is 12 volts, like 11.2. We decided like that's max speed. A train in a yellow block, right? Let's say a locomotive has just entered this block here, right? It passed this yellow signal. It's safe to be in this block, but it's got a red signal coming up. And because this is at yellow, this train is going to move at, I might be quoting these numbers wrong, I think it's 70% of power. The system will actually slow this train down so that it doesn't catch up too quickly to the train ahead of it, which is potentially the slowest train in the layout, right? Now, if there wasn't a train here at purple, let's say there was a train in another color. Let's say we had a train in this block here, the orange train, which just passed a green signal. We're pretending this train doesn't exist, so it's got a green signal. It's in a green block, but has a yellow signal ahead of it. That train is going to move at, I think it's 85%. Right? So a train with a green signal all the way ahead of it, coming up on a green signal goes at 100%. Yellow signal is 70. It might even be slower than that. It might be like a 50%. Just so it doesn't hit that signal early and then stop and get boring. Though it will if it gets there. And then this, so you can see like the more open space a train has in front of it, the faster it will go. If it's coming up on a red signal, it will start to slow down. If it's coming up on a yellow signal, it will slow down a little bit. And that's just to try and keep the trains sort of nice and spaced out. And it does kind of mean like the slower trains kind of chug along, you know, because their max speed is not as fast as the other ones. And the zippier trains, the Amtrak train is like one of the zippier ones. It often will like, you know, move ahead, slow down, hit a signal and stop. Then move ahead, say a signal and stop. But that's also prototypical behavior, right? The Amtrak has to wait for freight trains on its lines all the time. Yeah, it's a super, super cool system. Now, Jeff, I hear you asking, wasn't there a point? Yes, there was. And thankfully, I have 10 minutes left until the print is done to finish telling you this story. So, and Thomas has kind of, yeah, Chris, I swear I'm getting to it. This is all fun and games until, as Thomas says, until it derails, right? Until something stops and everything backs up. And then you really do end up in a situation where, you know, if these are let's just draw a second parallel diagram, right? If we have a derailment here, right? A train falls off the tracks, and these are true stories, train falls off the tracks, train picks a switch, like that stuff happens. Dust or debris gets on the track. The layout lives beneath, like underneath the 727, so we keep that very clean, but occasionally, like, you know, especially when we were coming back from shutdown, like dust accumulates when we run the automation in the 727, and dust falls down, and the trains are yay big, so they get derailed a little bit. Chris, you're hitting the nail on the head. How to alert train techs of derailments. So, the biggest challenge to the train techs, they spot or get notified of derailments pretty quick. Their workshop is right next to the layout. The trick is, you know, somebody from their buddies, our buddies in security or in guest relations or anyone else is like, hey, you know, train techs, you got a derailment. Or, hey, something's not moving over by Seattle, right? The trick is actually, the hardest part is finding the derailment because the layout is so large. And what the train techs requested of me, and what I have built for them is essentially this, right? If a train derails here, right, this signal will be red, which means a train is not going to pass it, right? So the next time a train gets here, right, maybe our purple train backs up there, this signal is going to be red. And that means the orange train will have backed up here. And so on. This signal will be red and going all the way back around. The most common failure mode for a derailment, sometimes an entire consist will stop. But most of the time, we will have a train that separates, right? Because the model train couplers are not terribly strong, they're little bits of plastic. Often if a train in the middle has a car in the middle of a consist has an issue, it will just decouple, right? And so the rest of the train, so like in this scenario, if we have, let's call it the red train here, we'd have the back half of the red train, you know, has derailed here and is sad, and its locomotive actually has run all the way around the rest of the track, and its locomotive is the last one here. So to get things going again, what the techs need to do is basically take this locomotive. We can fix the problem here, right? Usually just put the thing back on the rails, make sure that the true story that the Frappuccino is cleaned off of the tracks. That happened once. This is before my time, but I saw pictures. Somebody either dropped or threw a Starbucks Frappuccino onto the rails, all 3 main lines covered. Sticky, gross. It was a disaster. Disaster. But assuming you can get that cleaned up in short order, and usually it's just like picking up the pamphlet that some kid dropped off the balcony, right? You gotta take this locomotive and run it all the way back around the track to meet up with its butt end so they can start moving again. Now, like, if this is like one locomotive, yeah, you could like pick the locomotive up and just put it here, but most of the time this is like 13 or 14 railway cars. So the easiest thing to do is actually just grab this whole train and just like push it backward along the track until it couples back in here, and then re-enable the track and let things go again. So really what the techs would most like to know, because if there's a Frappuccino disaster, right, you're going to be able to see it, right? But if you just see you just know there's a derailment somewhere, what you'd really like to find first is where the locomotive of the broken down train has run all the way around to. So they're looking for this point. They've got 6 minutes left on the print. It's going to go great. So because, right, so all of the trains on this track have lined up here, and we're pretending for this experiment there's many more blocks all the way around here, right? This is all of the trains on this particular circuit, which means that this signal is going to be red, right, because it's seeing a train, and the signal right before it is going to be yellow. This was the point of telling you for, 20 minutes about railway signals on this model train set, which you have nothing to do with kabuki drops, but we're just waiting on a print to finish in 5 minutes now. What the techs have told me, have asked for, is a way to more easily identify this point, right? To come out to the layout and see, okay, train's not moving, where is this? And so the circuit that our nerdier of train techs asked for is like this light here, this yellow signal. What he would like is if a signal is yellow for more than 60 seconds or 90 seconds, which should really never happen. It shouldn't take that long for trains to clear the blocks in our layout. It'd be really helpful if this could start blinking. Right? That's all this. That's the entire problem statement. And I suppose I could have just told you that right off the bat instead of regaling you for 20 minutes about how train signals work. But I assume you're all nerds, so here we are. So the circuit that I have built for them and implemented into this PCB, and I swear there was a point, is basically a circuit that sits in line with the existing 12-volt relay circuitry, so that if the yellow signal is on in any signal for more than an adjustable amount of time, and they're adjustable from about 3 seconds to about 8 minutes, then the signal starts to flash, and that's the functionality that the techs had asked for, and that's what I provided. The circuitry, he said, seeing that they have about 3 minutes before the print finishes, is pretty straightforward. I don't have the schematic handy, but essentially, for those of you who know the 555 timer set of chips, it's a really simple timer chip, which maybe we should play with at some point, because they're super versatile, and you can do things like control servos or create audio circuits or all kinds of fun things. They're super versatile. Basically, there's actually 2 555 timer chips. They're just packaged together into something called a 556, and we take the ground and the existing power line for the yellow signal that just come in from a pair of relays, right, or a single relay, right? That's our positive yellow signal, and we wait a certain amount of time based on a capacitor and a resistor chain that are built into our 556 timer. And when the resistor allows the capacitor to charge up, it enables the second timer, which also is based on a resistor and capacitor chain. And that is just constantly charging and discharging that capacitor. When the capacitor is charging, we allow current to pass through to the output. When it is discharging, the output is off. So we have a one-shot, basically, timer circuit that is on, trigger. And our other timer circuit, when triggered, just goes on, off, on, off, on, off. So a really simple one-chip circuit. We actually have, there's 2 chips. There's an inverter needed to make this logic work in the right way. That, some indicator lights, and some terminal boards. That is the PCB I have been designing for the model train techs at the museum, in which you now know more about than you really ever wanted to know. But this is exactly the kind of thing that's great to have, like, PCB, you know, quick turn fabrication in your pocket, because like I say, this is not a complicated circuit. It's, you know, 2 chips, 2 sets of terminals, like 8 passives tops, some power, right? But we need 30 of them, because our system has 10 blocks times 3 main lines. So we could hand assemble the circuit 30 times, or we could fab a circuit board out, and then it's just soldering the pieces in the right places 30 times, right? Really simplifies the things. When's it going to be implemented? Depends when I can get around to it, frankly, but hopefully in the next month or 2. I'll do the circuit board design, I'll fab it out to JLC PCB, we'll get the parts in, and we'll get it in. The museum is open Wednesday through Sunday, 9:30 to 4. If any of you ever come to the Museum of Science and Industry, hit me up. I would love to, I mean, some of you I've met in person, many of you I have not. I'd love to meet you in person and show you around some of the nerdy things that happen there. Would be a really great time. And yeah, I would gladly show off this system in person. And like I say, maybe I should do a little, something you could do for a single-sided PCB and mill it, if I really wanted to. You could totally do it as single-sided. It's done on like a really simple breadboard right now. With the kind of timelines that we work with at the museum, like a 5-day turnaround or a 6-day turnaround, which is what like JLC will give you, or PCB New, or any of those are plenty fast for our purposes. We're not really doing the kind of rapid iterative prototyping that needs like single-hour turnaround. But you totally could, and if you have a PCB mill, and Thomas, I think you do, this would be a great project for it. Yeah, get on a train to Seattle. Yeah, I don't think you can see all of the cool stuff in this museum in a day, personally. Well, we're at 94%. Ah, finished with like a minute to spare. We're just doing the top. We're fine. We're fine. I could tell you a whole nother story about a whole other exhibit if I wanted to. I'm not going to. I'm going to have some beer and some hydration before we test this kabuki thing. But, oh, you know, speaking of, we started putting together this control board and then I didn't test it, which is on me. But let me zoom out quite a bit here, and I will test out that this actually works. And I think for tonight, I'm just going to power, I didn't put a voltage regulator onto this Demilight board. I think I'm just going to power it off of this programming adapter. So let's see here, which side, positive in. So turn on the DMX controller, and yeah, okay. So here, I don't know if you can see, because the Thomas coupler is not huge on camera, but as I roll the DMX controller up and down, I get, you know, the expected rotation of the servo motor, which is great. Thing works. We're really going off the rails, says Thomas. Oh my god. You're my kind of nerds, you know that? 97% there. So, we've got our Frankenshaft here. There we go, something like that. Let's see, we'll need, I think, steel these 2 hooks. Ooh, we're gonna need another hook, right, to be the actual support for the pipe itself. Let me see if I have another one in exactly this form factor, or if I have to steal it from a light. I suspect I have to steal it from a light, but yeah, theft is gonna be a thing. That's all right. We'll just steal it. I can use I think we haven't seen this camera view at all tonight, because there's nothing really to see in here this week. Although, I think I am going to replace this crappy webcam with the Epoch Cam system, which is like the use your phone as a webcam setup, so that when there are things to see in there, They'll be a little bit higher quality, because I think that'll be quite fun. And then someday, you know, if we end up doing an actual like little tiny show, maybe I'll put the nice camera, which is this tabletop camera, on there and get some really nice quality. But there's, I suspect, some steps to do before that. Alrighty. There's that guy. It's a little bit... Oh, partly the fit on here is not quite so good because these hooks work quite well when this is hanging down, but I sort of have this upside down with the rail up, and so it's just like, this is, as I stand it upward, this was just like, boop, just slipping back a little bit. But for the sake of a test and demonstration, I think that'll be fine. Speaking of test and demonstration, I think the print is done. Yes, yes. Yes, that's very good. Well, this has been a good barometer, because we've been printing things on stream for a few weeks now, which has been a lot of fun. And this was an hour print, which is probably about as long as we can feasibly like design and print a thing in a single stream on a Sunday night, right? If we were doing a 24-hour thing, it'd be a whole different ball game, but that's not what we're doing. All right, so the other challenge is, like, if I've screwed this up, we're probably not going to take another pass at it tonight, but at least we can figure out where I screwed up. But hopefully I haven't. So this is going to mount like so. We're going to put 2 hooks in like so and attach them here. Ooh, Thomas is testing a reflector and lens for a 24,000 lumen LED tomorrow, and see if the printed part melts and how the understanding of optics goes. That sounds like fun. I guess the other challenge of testing this upside down, right, is the shaft is not going to want to stay in this bearing. It's going to want to fall out. So we might have to, maybe we'll orient like this for the test tonight. So this, here, I will, before I get this totally obscured, it's a little bit hard to take out, actually. Hard to get your fingers in there to get that pin out. But you can sort of see, so like I printed this without supports, and you can see those first couple bridging layers are a little bit scraggly, but the fit of the pin is quite good. So I think it's just sort of an aesthetic issue. Chris says print time is dependent on how the stories are. Yeah, that's fair. Does that, so like if I have a real yarn to spin for you, I need to find like, you know, print one of those like super high detail like moons or a map of Mars or something. All right, so I'm just threading the rod in there, and we'll position the Thomas coupler, and we'll see how we think about alignment. The alignment's actually pretty good. Now, as Chris pointed out earlier, there's nothing that holds the Thomas coupler together yet. So for the sake of this evening, we'll use, as I said, one of my favorite tools, sticky tack, just to hold that together. Because I'm not too worried about solving that problem. You know, we could do a set screw, we could get clever about the design so that it like really snaps into place. Like there's lots of ways to skin that cat. So I'm not going to sweat it too much for tonight. More I want to get to this demo. Maybe if I just squish, yeah, there we go. Also could just hot glue. Wow, that's really ugly. We're just gonna glue this. So we'll thread that pipe in there. Certainly could do a magnet system. We'll just get that. What I wish I had handy, but it's across the room, is one of my favorite tricks is to you know, take a can of compressed air and turn it upside down and blast it at hot glue, because you get really instant cooling. Can be really helpful for like fiddly stuff like this that you're not sure is going to stay exactly where you want it while the glue cools on its own. Of course, with proper ventilation. All right, we'll just hold that in place while this cools. You can look at my cool face. You can look at the top of my head some more. I think y'all see a lot more of, like, this part of me than I do on a day-to-day basis, and that's fine. All right, let's spin this around. Yeah, let's spin that around. Get to the underside. And we'll put just a little dollop more glue there. Try not to glue the shaft to the body of the servo, if we can. Did I tell you all last week that I lost my tiny rare earth magnets? I feel like I did tell you that. I'm so chagrined. I have not found them yet. Although, to just give you a sense of like where my organizational brain is at this point, I made a surprise brunch for my wife this morning while she was out walking the dog, and I made some pancakes from a mix from White Knight Pancakes, which are a tremendous local Chicago company. They are so good. They're by an ex-actor who used to play the White Knight in Looking Glass Theater's production of Looking Glass Alice, and now he has his own pancake company. Super cool. Go support them. Made some pancakes, put a little melted butter in them. Super good. And then I couldn't find the butter for like maybe 10 minutes, and I was losing my mind. I knew I had to find it because we've learned our dog loves butter, and we cannot have a rogue butter dish wandering out the house. That was I was losing my. I was like, where is it in the fridge? Did I put it in the microwave? Did I put it in the stove and the oven? Like, where is this thing? And finally I realized I had just put it out on the dining room table because I thought we might want a little butter on our pancakes, but it took me 10 minutes to remember that I had done that. So, you know, like, finding and remembering where things are is clearly not going to be my strong suit at this point. But, you know, we're a year into some nonsense, so I think I can forgive myself for that. But, yeah, that's where we are. Ooh, Thomas says his LED, he says, he calls it a little thing. The LED is only rated at 14,000 lumens at 1,600 milliamps. But can go up to 3,600 milliamps with adequate cooling, a replacement for a carbon arc projector. Holy cow. You really probably do want to have some like serious ventilation in there in case because that thing could go up in some serious smoke. But a very cool experiment. All right, so like I say, we're not going to get to like actually dropping the curtain on this thing tonight, but just so we can see what it's doing, we'll put the classic engineer's blue tape on it. And yeah, there we go. That's awesome. Here, so let me do this in front view, just so the physics of it are in our favor. Let's see. So this would be the position of the fingers. Right, angled up a little bit, and the curtain's hanging off of those. And then when it's cue time, drop. And reset. And drop. So one thing I'm noticing is that unless the servo outlet here and this shaft are perfectly aligned, and like I said earlier, because of the physics of how these points work, they're not... This servo mount wants to like tip back a little bit, and that's causing this shaft to want to walk up this hook. So I might need a little bit extra reinforcement on this servo mount just to keep everything in line. But when they are in line, and you can see that beautiful gloppy Thomas coupler spinning there, that's going to be a kabuki drop. That's going to be awesome. Here, we can even, let's drop something. It's not going to be a curtain. It's going to be something really lightweight. But let's represent our curtain by this little servo horn. Oops, stay. This little servo horn. And at the precisely calculated showman-like moment, it can drop. Oh, it's very good. Let me do it again, because I'm just having a good time. Yeah, so... oh no, says Hamlet. I hope a servo horn from a 9-gram hobby servo doesn't fall from the Aris. Oh no! Well, that's I call that a success. I think that mount is quite successful. I think this servo mount, if anything, might need a little rethink, just to like give it a little bit more mechanical support back here, but that shouldn't be terribly hard to do. The alignment of this worked out really nicely. I think that's gonna be really successful. Could you make it a roll drop? You could. Roll drops are evil, but you could. You could convert this into a continuous rotation servo by taking its feedback pot out, right? And then, yeah, you could have it roll up or roll down. You come up with some way on yourself to, like, handle, what do you even call them? End stops, right? But the mechanism would be the same. You would just have to basically take the feedback out. So the way that you can convert a hobby servo, right, which is always traveling to a known position, and convert it to a continuous rotation servo is basically take the feedback mechanism out. So when it says, okay, it always thinks it's at home, and it wants to be, say, 10 degrees counterclockwise of home. So it'll start to travel counterclockwise, but because it has no built-in feedback anymore, it will just continue rotating counterclockwise until you tell it to be at home, and because its feedback now thinks it is always at home, it will stop, right? That's how you convert a hobby servo, a traditional servo, into a continuous rotation servo. Or at least that's how you convert a hobby servo into a limitless hobby servo. Let's see, does limit positions, can you use a center point on the servo mount to hit one of the small truss rods that run between the two long trusses? Oh, I see. So yeah, so you could, oh, I see, Chris. Like maybe we could use an existing hook from here down to an existing truss point. Let's just try that. I told Mary at the beginning of tonight, I was like, I think tonight's gonna be a tight 90. I think it's gonna be a really tight one. That story alone was like 45 minutes. So, you know, clearly I was wrong. Or a double duty drop that unrolls and then drops like a kabuki. That would be cool. Yeah, you could have kind of a similar mechanism, right, where it's just on like hooks and then is also wrapped around the shaft. And so it has to like unwrap, and then finally when the hooks are exposed, the next time it unwraps, it falls off them. That in theory would work. I don't see why it wouldn't. Let's see here. So it's gonna be a little bit fiddly, but Chris, I'm picking up what you're putting down. I'm gonna hook this onto the cross piece while plonking it into that mounting hole. Yeah, look at that. That's really solid. And honestly, now that we know you could do that, you could do that mounting, that really solid mounting for any of the Demilight mounts, right? Like, that mounting base is the same as a Demilight mounting base. So you could hang, if you needed one of these little guys for whatever reason or whatever the experiment was to be really solid, you could mount it in a 3-point position on this truss. That's really cool. And you get some additional spacing options, right? Because these 2 points are off-center. Show it easier on the Demilight, right? Like, to avoid the Phoenix connector hole, right? You have 2 that are on center line and 2 that are offset from center line. So I put this one in the back, but I could also have put it in the front, and its position would then line up not quite with this. Would be a slightly different position in relation to the truss. That's a cool feature. Thanks, Chris. Yeah, that's neat. I think that's going to give us some cool options to play with. Yeah, and now just like before. Yeah, but now that's really solid. That's great. Here, we'll come back to the physics. The pipe does want to, like, walk its way out the hook when it's sideways, but with it in this orientation. Yeah. That's awesome. All right, so some more challenges to come in Kabuki Drop Land, and I don't know that's what we'll come right back to next week, but it's a good project to keep churning on, right? We've got to figure out how some hooks would get on this shaft. We got to solve a couple of like minor design challenges with the Thomas coupler, right? The shaft to the attachment here, which is probably just a change in 3D design, and how the shaft, the coupler couples to itself. But again, like, there's lots of different ways we could solve that. And some hooks. So yeah, so hooks, coupler to rod, coupler to itself. But then I think we're in business. And that's really cool. You know what makes me think when I hear roll drop, and this is be a good place to end, I think, just talking about the micro stage because we haven't visited it all this week. Let's see if that's, and the webcam is still as crappy as ever. But here's a view of like the working environment as it exists currently, right? And one of the challenges with it, of course, is it's very visually busy. Like if this was going to be the thing to show off programming on the micro stage, I mean, some things like storage. Gotta go. I want to take this blonde wood up here and take it to black, dress the cabling a little bit, the phone probably get hidden. But this big open side here, right, sort of right next to me where I access it from to play with it on the stream is kind of an issue because I'd want it to be mostly open, but I also would like the ability to easily sort of mask it off for showing things off. So one thing could do is like, you know, hang some little, like, basically black drapes, like black masking in panels here, so I could still reach through it and manipulate it or dress it out of the way. But if we get really clever someday, what if they were roll drops on this side? So it's like, oh, here's a demo on the microstage, blah, 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 programming, isn't Jeff so smart, look at those cool effects. Ooh, let me tweak something, activate roll drops roll up, work on project, roll drops roll down, continue programming. That will almost certainly never happen, but it would be very cool. Mostly because roll drops are awful. We did like 4 different roll drops in my 3 years at Chicago Shakespeare, and none of them were good. None of them were good. Even the short ones, even like the 12 and 14 foot roll drops, none of them are good. But maybe 18 inches is the magic height for a roll drop that works, so I'm willing to give it a try. Oh, Thomas asks the size of the brass rod, which is, where are my calipers? Here. I'll show you. It is 4.71 millimeters or 0.185 inch outer diameter. And I know this was purchased as a standard size, so I suspect that is 3/16. But those are your actual dimensions if you want to. And I guess I don't know if that would be 3/16 nominal. These were purchased from like both from the hardware store and from American Science and Surplus's like metal tubing hobby rack. So that's where I go to the hardware store or your local. Oh, inner diameter. This is. Here, I'll give you, the easier for me is going to be sidewall thickness. So let me give you that. So sidewall thickness is, I'll do it on camera, so if you lose the numbers, they're on the YouTube here. 0.015 inches or 0.35 millimeters is the thickness of that tube, more or less, and you can come up with the inner diameter from there. How's that? Yeah? Awesome. Let's call it for the night. Cool progress. It's like the moment, it's like such a simple little, it's just a servo turning a shaft, but like there's just a moment in every project where the thing starts to look like its final form. That's super fun, and for me, that's this. I mean, yeah, even knowing that it's held together with like hot glue and tape and hope. Yeah, super, super cool. Ooh, Thomas has an updated coupler to send me. Ooh, yeah, please do. Do you want to just send it to my DMs on Twitter @JeffersGlass? And if you out there on YouTube land have things you want to show me or ask me, that's the easiest way to do it, @JeffersGlass on Twitter. If you liked what you saw tonight and you want to see more, you can subscribe. If you want to be notified, you can hit that bell or leave a comment. All the things. Actually, I should say, if you have questions on this project, do feel free to leave me a comment. People often, with some frequency, comment on past videos, sometimes with really specific questions, and I love that. Like somebody chimed in on the Andon video the other day, was like, hey, what is that specific metal box I see there? I'll go find out what that metal box is. If you care enough to leave me the comment to be like, what the heck is that thing? I care enough to go and help you figure out what that thing is. So yeah, leave a comment. Find me on YouTube. Find me on Twitter. Yeah, as we said last week, I want you to be in my DMs, but not in my DMs. You know what I mean? More information about this project in general is in the link in the description @Jeffers stuff. jeff.glass/Demilight. Build instructions, STLs, Gerber files are there. You can call me anytime at 815-0-MALORT, and that rings the big red phone back here, and I love to get phone calls from strangers. It's kind of delightful. I'll be back here again next Sunday night doing something. Maybe more kabuki, maybe lights. I don't know, something nerdy. I'll be a nerd here. I assume you'll be a nerd here. We'll all be nerds here. But in the meantime, stay safe, wash your hands, hydrate, get some good sleep, enjoy another hour of sunlight in the evenings if you're here in the States. If you're anywhere else, I hope you already have sunlight in your evenings. And I will see you next week. Thanks, y'all.